This presentation is an introduction to the crash course, which is a much longer body of material. My purpose today, though, is to give you the highlights from that, because the crash course is a lens through which I look at the world. It's my way of making sense of a lot of seemingly disparate, troubling events. And what I want to do is I want to share with you how I do that, what the framework is, how I look at these things, because I think that you too, when you see the world in this way, you'll be able to make sense of it, and you'll be able to predict what's coming next. So what are some of these incidents that have been going on? Well, prior to April of 2000, none of us had probably heard of the Deepwater Horizon. You, like me, probably had never thought of this particular drilling rig. But on April 21st, 2010, this thing was in everybody's consciousness. And it is the source of the largest environmental disaster ever in the United States history. So how did this happen? Well, we might be tempted to think this was just what happens when human error and a complex project come together in an unfortunate set of circumstances, and that's partly true. But it's also connected to the global financial meltdown and the riots that we've been seeing in Greece and the unrest we've been seeing in Spain and the unrest that we may be seeing in other countries as it goes forward. So how is it that the financial system and the Deepwater incident, how are those connected? And you may have also noticed that the stock market, which hit a peak in 2007 and then took a dizzying plunge into March of 2009 before recovering for a little while and then going through some more volatility. You might have noticed all of this as well and been wondering, well, what does this have to do with the Greece situation I've just been talking about, if anything? Well, how about the Deepwater incident? How are these and dozens of other incidents, how are these connected? Well, they are connected. I want to show you how. This story for me begins with the economy, the first E. The economy is the way in which we organize ourselves. And without a functioning economy, all of our hopes and dreams really will not come to pass. We need a functioning economy to preserve our standard of living, our quality of life, for us to have opportunities. We want to have a well-functioning economy. So I look at the economy through that lens because it's very important that we have one and that it's functioning well. But there's another reason I look at the economy as the prime lens through which I look, and that's because we get very rapid, very quick, instant feedback on the world around us from the economy. Through the financial markets, through behaviors and interrelationships of prices, we get a lot of really good information. But, of course, the economy, that is the lens I look through, but it's not the most important part of this story. Without energy, the economy actually has no meaning. We could have all the money in the world, but without energy, we would really have nothing. We would not be able to build an economy. And there's a very interesting story coming up around energy, and particularly around petroleum, around oil, around the fact that oil may well, within the next few years, be peaking in terms of its total output. This doesn't mean running out, but there's a really interesting story about how our economy is put together and how it relies on energy. And when we put those two pieces, we get a very interesting story emerging. But there's a third E in this story as well, and that's the environment. And for me, the environment in this story is going to be about resources and about how those resources within my lifetime or maybe my children's, many of these are going to be peaking as well in concert with oil. And so this in itself, listen, there's really nothing here that should be too frightening about this story, but there is something that we really need to understand, and it's about how this is put together. So when I put all of these E's together into one spot, I can boil the whole crash course down into one statement, and it's that the next 20 years are going to be completely unlike the last 20 years. Now, this might be a little bit trite sounding, right? But what it really means is that the kind of change I see means that modeling what we think is about to happen based on what just happened is going to be really the wrong way to approach this. We've got a really sharp corner coming up. We have to be open to the prospect that there are some real changes coming, possibly disruptive changes. Here's how economists see the world. Don't worry, we're not going to have a lot of math in this. So what I want to do for you here now is let me simplify this equation, in case you don't remember your calculus. There. Economists see the world in terms of growth. This is an equation that comes off the Federal Reserve website, and that is the equation for economic growth. Not just any kind of growth, a special kind of growth. It's a kind of growth that sounds benign. Hey, we want our GDP to grow by 3% next year, 4%. But we want it to grow by some percentage every year. So this growth is actually a type of growth known as exponential growth. And it has powerful implications for what's about to come next. And it has enormous implications for your lives and for the lives of those around you. Now, to understand why that does have such huge implications, I have to start with this stuff here. We have to answer a very basic question, which is, what's money? Now, I don't care what your money looks like. I don't care what country you live in. I don't care what pictures you have on it. I don't care what color it is. I don't care what anti-counterfeiting measures you have. All money in the world today shares one common characteristic. And that characteristic is that all money is loaned into existence. Now, I don't have time to go into that in this presentation, but if you go to the crash course online, you'll see that I spend about 20 minutes going through this particular statement because it's that important. But this statement, I didn't make it up. This actually is a full direct quote off the Federal Reserve website. So go to the full crash course and look at it and see what this means, but this has huge implications. And what does it mean when we say all money is loaned into existence? Well, it's an important enough statement that I call it one of the key concepts in the larger crash course. And it has this implication. It means that at any moment in time, there is always more debt in our society, in our system, than there is money. Well, why should that be true? Well, let's take it all the way back to the very first moment. There's no money in the world. I need $1,000. One of you out there is a banker, and so you agree to loan me $1,000. So you do. I now have $1,000 because that money was just loaned into existence. And I take that and I can do wonderful things with it, right? But what happens in a month when I have to pay that $1,000 back? Well, what do we know about loans? The principal component, and they have that interest component. So I go to pay back my loan and it's now $1,000 plus interest. Where does that money come from? It doesn't exist. So now you have to loan me the money to pay back the interest. And we do that again and again and again. And eventually you end up with this statement here, which is that there's always more debt than money in the system. So if you don't bond well with the theory on that, here's some data. In the United States today, there are $52 trillion of total debt in our system. That's about $14 trillion of money. 52 trillion of debt, 14 trillion of money. It's clear that you couldn't actually take all the money and pay back all the debts. It wouldn't be possible. There's just not enough. And so this has profound implications because what it means is that perpetual growth then is a requirement of our money system, of our banking system, by extension our economy. So when we say our economy needs to grow, what we're really saying is that it likes to grow. Our economy does not do well when it's not growing. In fact, it's so well embedded in our terminology that I invite you to look. As you read the newspapers, you will see this term. Economists will actually say, last year the world economy experienced negative growth. Because we don't actually have words for the opposite. We talk about growth always. And there's a really interesting thing that comes out when you have constantly growing debts. And that's what we have, and we've had them for quite a while. So when we think about how all money is created from debt, we find, I made this statement that there's always more debt than money in any given society. And so this problem is a predicament, however you want to phrase that. There is a lot of debt floating around out there. It's a global phenomenon. So what we're looking at in this chart, we see Spain all the way on the left, and we go to Italy and Germany and the UK, the EU, US, France, and Greece. There's two bars in there. There's the blue bars, those little tiny ones across the bottom. Those bars are the ones that we read about in the newspaper all the time when they say, the United States debt to GDP is not that bad compared to Japan. The green bars, though, are the ones that include all of the liabilities of a country. So in the United States and in the UK, those things happen to be things like pensions, entitlement programs, other liabilities. And so if we look at this chart here, what we'll see is that instead of having debt to GDP that's close to maybe, 100%, we see numbers that are over 500%. We see that the United States and the United Kingdom and other countries, instead of being ahead of the pack, are actually right in the middle of the pack. So when we look at this figure here and we see those kinds of numbers, we don't have any historical examples anywhere where countries got to this level of indebtedness and were able to get out of that problem by either growing their way out of it or doing anything other than printing or in some way entering a form of default onto that debt. So we're really in brand new territory. That's why this is really important information. So when I look at all this debt that's sitting in all the world economies, I can sum up what an economy is in just two words. An economy must grow. That's what it must do. So when we take this first E, instead of thinking economy, I want you to think of something that must grow. And by must, it's not a law. I'm saying must as in, think about 2009. We experienced roughly minus 2% shrinkage or negative growth in the world economy, and it felt like the wheels were falling off. Plus 2% growth, we wouldn't be here having this conversation with the same level of urgency. People would be saying, oh, that worked out fine. So when I say it must grow, I'm saying it's really quite unhappy when it's not growing, and it's pretty much okay as long as it's growing. And it's not by that much. A couple percent here or there makes all the difference in the world. And so why should that be? And what can we connect that to? Well, I need to talk about this stuff called exponential growth at this point in time. And this is a very special type of growth. And by exponential growth, I'm talking about something that looks like a hockey stick if we charted it, right? We're looking at an amount of something over time on this chart. So amount on the vertical axis, time across the bottom. And in this particular example, we're actually looking at a chart of something that you should be pretty familiar with. This happens to be a chart of population. The green part is history. The red part are UN projections for the next 40 years. And we have to chart this over a few thousand years because human population has been growing at about 1.25%, sometimes 1.5%. It hasn't been growing all that fast. But we'll see two parts in this chart, right? We've got this long, flat part, and then we turn a corner, and all of a sudden, it has a steep part. Now, for anybody who's actually a mathematician, you'll realize that I'm actually pulling a fast one on people. Because if I fiddle with that axis, the left axis, I can make this hockey stick turn a corner anywhere I want. It's a trick, right? So if I made this, instead of going to 12 billion, if I made it go to 1 billion, this looks like it makes a pretty vicious hockey stick in about 1910. So we're dressed very differently, and I'm trying to scare you back in 1910 with some alarming data, right? Or if I made the left axis go to trillions, we don't even see any curve at all. It just looks like a flat line. So what's with this trick then? Well, it's not a trick if you can fix the left axis. Now, what if somebody came along, scientists said, well, we've added up all the water, all the soil, all the possibilities for growing food. We've done that, and we've decided that there's a physical cap on the number of people that can fit on the surface of the planet. Okay, now it really matters where the bend in that elbow is, and it entirely matters where you are on this particular curve. Being on the flat spot versus being on the steep spot, entirely different experience. I have this cap sitting here at somewhere between 9 and 11 billion, but there are scientists who think that all that's going to be available post-oil will be something closer to maybe 1 to 2 billion. So we have an interesting cap here that we can put on. So how can we understand this a little bit better? What else can we look at? Well, here's a chart of oil. So this is the amount of oil that's been produced. And we see, again, it has a flat spot, and then we turn a corner, and then we've got this steep spot. And I'm going to put a cap on this because we have very reliable information as to the total amount of oil as a rate that we'll be able to pull out of the earth. We are either at that rate currently or we're within a few years, depending on who you listen to. But we're close. We're not 40 years away anymore. We're maybe 4 years away. A blink of an economic eye. It's upon us, potentially. So this, where we happen to be on this curve, again, extremely important. And I can show you hundreds of charts, all of which are not showing you linear behavior. They're showing you exponential behavior, nonlinear behavior. They look like hockey sticks, ranging from environmental things that I have listed here, but I could be showing you number of Krispy Kreme donuts sold, number of cars on the road. I could be showing you lumber produced for houses. All of the charts look the same. So, point being, you don't live in a linear world. You live in a world that's denominated and dominated by these curves. So what does that mean? I mean, how can we understand that? The thing about being a human is we think linearly. That's how evolution designed us. We don't think exponentially. So how do we understand it then? If we're sort of saddled as not really able to understand this, what do we do? Well, what I want to do is I want to talk about this exponential growth a little bit more. And in particular, I want to give you an example so that you can understand this a little better. So let's think about how we can understand this chart. And here's the example I'm going to give you. I have a magic eyedropper. And what's magic about it is that when I put this drop of water in my hand, it's going to double every minute. So imagine I put a drop on and we wait a minute, and then I have 2 drops in my hand. And then I wait another minute and I've got 4 drops. And then I wait 6 minutes and I can just about fill up a thimble. Do you understand? Do you have a sense of that growth? All right, so I want you to follow me now. We're going somewhere. We're going to Wembley Stadium, and this is my show, so I'm going to do two things. I'm going to make the stadium watertight, and I'm going to handcuff you to the highest row of bleacher seats. 12 o'clock tomorrow, there you are handcuffed to the highest row of bleacher seats, and I go down onto the pitch, and I put one of these magic drops out in the middle, so small you can't possibly see it. The question is this. We start at 12 o'clock, the magic drop comes out. How long do you have to escape from your handcuffs? That's the question. Is it days, weeks, years, months, seconds? How long do you think you've got? There's a couple answers here. Anything. Just shout one out if you've got one.
2 days.
2 days. Anything else?
4 hours.
4 hours.
6 hours.
6 hours. Okay, we started at 12 o'clock. You have until 12:50 that same day. All right, so I see some skeptics out there, right? So this guy's thinking, he's way off in his guess as to how big Wembley Stadium is. So I'm off by 100%, all right? 12:51 for you, okay? All right, so that's actually not the important question. This is the important question. At what time is this park, this stadium, still 97% empty space? And how many of you realize the seriousness of your predicament? 12:45. 45 minutes, we fill up 3% of the park. 5 more minutes, it's over. It's completely full. All of human history till 1960 to put 3 billion people on the planet. 40 years for the next 3 billion people. We tend to think linearly. We hear about 70 million new people on the surface of the planet every year. That's population growth. And that sounds linear to us, 70 and then 70 and then 70, but it's not. And the really interesting part about this is that where you are in the curve makes all the difference in the world. So here's an example. I want to go back to oil consumption. Remember I said, well, okay, we've got this oil consumption. It looks like a hockey stick chart. So right here, oil shock 1, early 1970s. It's a geopolitical event, right? Jimmy Carter comes out and gives this incredible speech saying, we have a real problem on our hands and we're going to have to think about energy and we have to fundamentally change our relationship with energy. And we didn't. We took that opportunity in the United States, at least, to not engage in that material and go a different direction. All right, that's fine. And now we have oil shock 2. That came about in July of 2008 when we hit $147 a barrel. And that one happened for a very different reason than the first oil shock. The second oil shock, we saw something that we'd never seen before in the data. For 6 quarters, for a year and a half, in the run-up to that July 2008 moment, out of those 6 quarters, supply had been exceeded by demand for 5 of those quarters. We'd never seen that before. Now they're talking about congressional commissions, was it speculators? There might have been people speculating on the price of oil, but they were doing it for a very good reason. They were looking at a fundamental supply-demand mismatch. We were pumping as hard and as fast as we could. If you were an oil producer, you had every motivation to get your oil out of the ground when it was over $100 a barrel. So we were pumping as hard as we possibly could, and we still got beaten in terms of supply by demand for 5 out of 6 quarters. That's a powerful moment. So it means that the mistake in this story would be thinking that because we had 30 years between the first 2 oil shocks, that we've got another 30 years between oil shock 2 and oil shock 3. And the reason for that is we're not on the same part of the curve anymore. We are in a fundamentally different place because we can reasonably predict where the cap is on this. We know how big this stadium is. So we are in a very different place on this curve, and it's important to understand that. And this is why I spend a little bit of time talking about exponential curves, about exponential functions, because that's the world we live in. We're surrounded by these things. They interact with each other. They intersect. And it's a key concept of the crash course. It's another one. Yeah, I say they're everywhere. We can find them in all 3 E's. But the key thing I want you to take away from this is speeding up. Because we live in a nonlinear world, these charts have a way of intersecting with each other and create this impression, if not the reality, of events speeding up. And it means that instead of having 50 minutes to figure out how to get out of our handcuffs, knowing where we are in some of these curves, we might realize that we only have a few minutes left in this analogy in order to get things right. And by getting things right, there's some framing I want to put on this. I want to differentiate between problems and predicaments. Problems have solutions. Predicaments have outcomes. You can manage outcomes, but you can never, if you're facing a predicament, get yourself back to your original starting condition by simply applying a few solutions. And it's critical because if various countries around the world are treating these symptoms that I'm talking about as if they're problems and don't realize they're predicaments, it means that we might waste a lot of time on things that don't work. So here's an example. Here's a couple of gentlemen, they have a problem on their hands, right? There's a variety of ways that this could be solved. We could put a solution. We could put a big mattress underneath and they both end up in the same condition they started in, or maybe one guy climbs down or the rope gets lowered. Lots of things we can do. This gentleman, no matter how fast he pinwheels his arms backwards, right, he's going to get wet. He's now got to manage his situation. His outcome is, do I land on my feet or do I belly flop? Right? So that's the difference between problems and predicaments. One has a solution, the other only has outcomes. So where are we really in this story? I want to burrow into energy just a little bit more because I told you it's really critically important. This is the linchpin to this entire story. Now, when we look at energy in the United Kingdom, we find that in this chart we're looking at red designates that the United Kingdom is a net importing country for energy, in this case petroleum. Yellow means they're exporting, right? And blue means there's some combination of the two. The United Kingdom turned import dependent again in 2005. That's exactly equivalent to what happened to the United States starting about in the early to mid 70s. So we look at this situation and we see this, again, that whole peak of production that we see there in that yellow part up through the UK story here, those are the North Sea fields. They came online, they were immense, they were hugely prolific, and they're in rapid decay at this point in time. The North Sea fields are producing about half what they used to produce at peak at this time. And so this situation for the United Kingdom suggests that they not only turned into an energy importer in 2005, but they permanently turned into an energy importer in 2005. And that's a situation that needs to be looked at and understood. This next chart that I'm going to show, this is the one that really shocked me when it came out. The International Energy Agency is an international body whose job it is to project energy demand and supply. And they do it across everything, electricity, coal, nuclear. But one of the pieces they look at is petroleum. And this chart really shocked me when it came out because this is in 2008. All the way up until 2007, the International Energy Agency had always projected how much oil we were going to get by using this very complicated formula. They would say, well, how much do the economists say we want the economy to grow? Okay, that's how much oil we'll have. In 2008, they did something different. They said, hey, what if we actually added up all the fields and said how much is coming out of them? So they actually did a fundamental bottom-up analysis. And when they did, they got this chart. And this chart really shocked me because it said a couple of things that really were just absolutely unique and that I hadn't seen before. The first is that, I'm putting a line here up on 2010, which is where we are today. The first is that, look at the big blue spot on the bottom, that big blue wedge. That's crude oil from currently producing wells. That's a euphemism for cheap and easy. That's the stuff where you stick the straw in the ground and the stuff comes shooting out, and your job is to collect it. The next blue line that we would see, the next blue smear there, the light blue, that's from fields yet to be developed. Some of that might be cheap and easy, but not really. Most of that stuff is actually harder to get to. The Deepwater Horizon, for instance, was drilling after a formation that was 18,000 feet down in total. And if we completely tapped that reservoir, we would have gotten about 12 hours to 24 hours of global use of oil out of that. That's how much we were chasing. We are past peak for conventional oil. That this admission came out in 2008, came out in November, shocked me that we didn't see it actually on the front page of literally every major publication in the world. It was something you had to dig for, and it's actually one of the most profound charts that I've seen in a long time. And so when we look at this, we find out that we are past this peak, and even here there was a second thing that was shocking. If we look at the total amount, add up all those colors, and go to the far right, and we're in 2030, and you see that's at about 105 million barrels per day. Just in 2007, the IEA was projecting that we were going to get to 130 million barrels per day. So they completely trimmed back the amount that we were going to get. And since then, we have had a number of other agencies, particularly the International Task Force, the Industry Task Force on Peak Oil, which is a UK consortium of 5 companies, including Virgin, Richard Branson's group, companies that care about oil deeply and its availability. They did their own bottom-up analysis and asked the question, how much oil could we possibly get out of the ground as a flow rate? What would that look like? And they came up with a number that puts this cap on. They were said somewhere around 95 million barrels per day, but that's the cap. Now, this is a really interesting development because we need constant growth in petroleum in order to run our economy the way we expect it to run and are counting on it running. And this is a huge wrinkle in that story. We have a story now that says prudent adults can look at this data and can say that without some fundamental change in this data, we know that we are very, very close to peak at this point in time. And that's assuming we continue to invest enormous amounts of money and increasing amounts of money in exploration and discovery. So I want to raise this first Q, this quantity Q, and I want to say quantity of oil is important to this story, and that's the one you'll read about. How much oil is coming out of the ground? Is it 95 million barrels? Is it 105? Can we somehow sneak that to 120? Quantity is important, but there's something else that's just as important that you won't read about as much yet. And here what I want to talk about is not how much money it costs to get oil out of the ground. I want to talk about how much energy it takes to get that oil out of the ground. I don't care if oil is $1 a barrel or $10 million a barrel. As soon as you're using 1 barrel of oil to find 1 barrel, you're just spinning your wheels. So this is what this chart is trying to step through here, is talk about, it's just a theoretical chart. But what it's saying is, how much energy does it take to get energy? And so if we look at this, the red part is the energy used to get energy. That's what we're investing. The green part then becomes the surplus energy that's available to society. That's the stuff we run our economy on. And we do all kinds of things with it, right? We drive our kids to soccer practice, we take trips to Norway, we do things with that. So the green part's what we care about. The red part is the part you have to invest to get it. Forget the dollar investment. I'm just talking energy investment again. And so when we look at this chart, we see that it crosses at 1 because, right, at time you're going, getting 1 out and putting 1 in, you're at basically a 0 return. And then these percentages up the side say, well, what's the percentage return? So at 50, all the way on the left, we're getting 50 barrels out for 1 barrel put in, 50 to 1. That means we're getting a 98% return for a 2% investment, 50 to 1. And what's interesting about this chart is we can start to plot things on it. We can say, well, how much energy were we getting back when we were exploring in the 30s? We were getting 100 to 1 returns. It was just nothing but green under there practically. And that's okay. By the 70s, it looks like we were somewhere in the range of maybe 25 to 1. It's still a huge amount of green under that story. So that's fine. You probably don't even notice anything is missing in this story yet. 1990, 18 to 1, 10 to 1, we're still in this range, but we're still up in this upper part of this curve. Again, this is not a linear curve. We don't just draw a straight line from the left down to the right. It trundles along and then drops off very rapidly. The deep water find that I was talking about, those where we're going 18, 20, 30,000 feet under the floor of the ocean, now we think that those are returning something closer to 3 to 1. That doesn't sound too bad, right? 3 to 1? But I want you to think about it this way. The green is the part that we arrange all of our economy in, all of the complexity, all of our job descriptions. Everything that we produce is in the green part. So if we have to suddenly start living just on deep water finds, we live in a world that looks like this. And it's a very different world. You can fit a lot less complex society into that green area than one where we have much more green above it. But what if we did biofuels? What if we did corn-based ethanol, which is something we've invested a huge amount of money in the United States? Well, that has a return of about 1.5 to 1. And so if we wanted to run our society on corn-based ethanol, this is the world we'd be living in. We'd be trying to cram all of our society into that little green part down there. And we'd be horribly confused if we just looked at it economically, because we'd say, gosh, it makes political sense. Farmers love it. It makes economic sense. We're pouring a bunch of money in, but it's not working. We don't know why. And the reason why is because we're not looking at the right part of the story. We need to be looking at the energy that we get back out. Again, the dollars don't matter. The dollars are just an abstraction we put on top of things afterwards. This is the story that really matters. So when we look at energy declines in terms of return, it means that quality is an issue. You will hear about and you will read that we have 2 Saudi Arabias locked in the tar shales. Or the oil shales out in the West. That's true, but the energy return on those is horrible. So quality, when we're looking at our hopes and our dreams to say, well, there's the tar sands in Canada are great, the tar shales, we have all of these things, they have very poor net energy returns compared to the finds that we used to have. And so that's a critical part of this story. So it means that we can sort of sum this all up by saying we have an economy that must grow, and it is connected to an energy system that we can reasonably predict can't grow. And when we're looking at that can't grow part, I want you to think both about the quantity and the quality, because those are both critical components of this story. The quantity part we're reading more and more about. The quality part is still not part of our national or global narrative yet, but it will be coming. Now, I want to take the same sort of a story and we're going to roam into the 30, the environment, and I want to talk about a similar sort of a story around this. This is one of my favorite pictures. This is a couple of gentlemen. They're sitting on something that they found, and it's recent enough, I guess, that there were pictures available to be taken, so this is late 1800s. And what they're sitting on is a copper nugget. That was what was available when we first came into the United States and started looking for resources. And guess what? We ran out of nuggets like that. Those all got scooped out of the stream beds pretty quickly. And so that's okay. We went on to the smaller nuggets. That's what you do, right? You start with the good stuff and you go to the slightly smaller stuff, and we ran out of those. And that's okay. We went to copper ores. This is beautiful stuff here at about 10%, bright green band. It's lovely stuff. And we kind of ran out of that. And so in the United States now, this is what our largest copper mine looks like. This is the Bingham Canyon mine. It's 3/4 of a mile deep, 2.5 miles across, and it used to be a mountain. The copper ore grade that comes out of this mine is 0.2%. And we're not doing that because we like to give our engineers challenges, right? We're doing this because that's the stuff that's left. And instead of thinking about 0.2% and how much does that mean we have to pay for copper, I want you to think about the energy required. You know, mentally put on a backpack, load it up with some 0.2% ore, and start walking up that hill, right? Just think about the energy embodied in getting that stuff from the bottom to the top. And once it's up there, you still have to process, crush, leach, refine, smelt 500 pounds of earth to get 1 pound of copper. So this is where we're at after only 150 years of industrialization of our economy. Just 150 years, from giant nuggets and stream beds to giant holes in the ground to get this very minor stuff out. So the question becomes, well, what does the next 150 years look like? Again, this requires a huge amount of energy to prosecute. But the story in copper I've told you, we could go to many other things. So here's a list of elements. This says how many years of reserves globally are left in these various elements if we continue to grow their production at 2% a year. Look at the stuff on the left. There's 10 years. 10 years of silver left, maybe. 10 years of, maybe 15 years of antimony. Maybe 15 years of gold. That's what we know about. Now, it's possible, maybe there'll be some other huge finds, but what we know about reserves at this point in time, they've been reasonably well mapped, and we can actually look through the windshield of the car we're driving and see the end of certain key minerals. But by the time we're down to the last few decades of materials, we are down to the stuff that represents giant holes with very dilute mineral and ore concentrations. So that's part of the story. And so what I want you to think about then is when it comes to resources, think about generalized, this is a resource extraction profile, the big green one. We find all the great big nuggets, and then we find the smaller nuggets, then we're down to the 10% ore grade, and then we're down to the hard stuff. And guess what? We'll find that we will get more and more and more stuff out of the ground, and then we'll get less and less and less. But the thing about that story is not the less and less that's really critical, it's that the amount of energy that's required to get that stuff out of the ground, because it's farther, deeper, more dilute, doesn't go up linearly. It vaults up enormously. It's not linear. And by extension, that would mean that the cost would also be going up quite a lot. So the question before us is we look at the potential peak of oil and we ask ourselves, what's connected to that? How many things are connected to that? And that is connected to literally everything. We could say a peak in oil might well represent a peak in just about any other key mineral resource that we can think about. If not now, maybe in 10 years. If not then, in 20 years. I'm back to my statement. The next 20 years are going to be completely unlike the last 20 years. Because now, in this next 20 years, I can reasonably foresee a period where we're going to be asking the question, are we going to be dragging that copper up out of the ground, or are we going to be using that oil for something else? We might have to start making that trade-off. And that's something that we've not had a lot of experience with yet as a culture, or as a society globally. So now we've got this thing that must grow, right? It's connected to something that can't grow. And we have some signs that there's a whole lot of depleting going on in the environment through a lot of key resources. And I picked minerals, but you know what? We could do this for fish. We could do this for soil. We could do this for fresh water. We can do this for all kinds of things which are either non-renewable or even renewable natural resources. And we put all these things together, and for the environment and the energy pieces, I invite you to think about both the quantity and the quality, because those are both critical elements of the story. And I've connected all three of these chunks together because they're all connected. And it's my belief, the reason I give this talk is I don't think we can just look at the economy and solve the economic problems without understanding that there's a connection to energy and that there's this connection. We have to look at all three, this connection to the environment too. All three. Because it's like a balloon. We're going to squeeze, we're going to fix the environment, and it pops out in these other places. Oh, so we're going to have to really think this through. And the question that I come up with then, when I look at this, is this something we can tweak with a few policy fixes? I mean, really, what are we facing? Is this a problem or is this a predicament? That's the key question I have. Because if it's a predicament, it means we're going to have to think about managing the outcomes. We have to drop the illusion of thinking, you know what we're going to do here? We're going to fix a few things and we'll just get back to how everything used to be because we fixed a few things. We're going to have to manage for a very different sort of scenario, a very different outcome. And it raises this primary question for me, which is, well, what do we do? What does that look like? The first thing I think we have to do is I think we have to understand that this represents possibly, if what I've told you is true, possibly an enormous shift that really represents a very gigantic structural lasting change. The word for that would be it's a shifting paradigm. I think this word is overused a lot, but I think this is an actual use for the word that is meaningful. So what do I mean? So the old paradigm. In the old paradigm, we might have been able to reliably count on more energy every year. That was just part of the landscape. Yeah, you know, we had to secure trade routes or make sure that the oil was coming from maybe tricky parts of the world, or we had to pay more, but we could always count on more. That was the old paradigm. What if the new paradigm going forward is we have slightly less energy every year? What does that world look like? What changes? What do we have to stop doing? What should we start doing? It's a completely different world. We, as a species, do not have experience in that new paradigm. There's always been one more continent, another resource we could tap, a new source of energy. We went from wood to coal, from coal to whale oil for a little bit, from whale oil to actual oil. What's next? That's the question mark in my mind, because nobody has defined that next yet, right? So it's a new paradigm, slightly less energy each year, huge implications. What if the old paradigm was that we could count on more and more resources each year? All the things I mentioned, copper, tin, bauxite, fish, whatever those things happen to be. What if the new paradigm is slightly fewer resources every year? Then what? What changes? Well, our entire economic model suddenly doesn't, the model based on perpetual growth, doesn't really operate in that framework. There are other economic models that could, but the one we happen to all be living under and we've organized ourselves around doesn't really operate well under this one. I haven't seen any good description yet that says, here's how this is going to work as soon as we get into that new paradigm. So I think we can see this paradigm of slightly fewer resources on a go-forward basis. I think we can see that certainly within the remaining portion of my adult lifetime. It's there, if not already being upon us. Now, how about if the old paradigm was reliable economic growth every year? This is an important paradigm because this is why when you look at stocks or bonds or any of these financial assets that many people count on as a descriptor of their wealth, those all absolutely count on reliable economic growth every year. That's a huge portion of their value. What if we have slightly reliable economic shrinkage every year? Well, what happens? What changes? Everything changes. How we value things, what we invest in, what we won't invest in, our time frames for things, all sorts of things start to get modified. There's enough of a chance that what I've described is potentially true, that there is this new paradigm somewhere right before us, that I think it's time to admit that what we really need is we need to absolutely start thinking of non-status quo solutions. That in our society, that in our businesses, that in our political structure, we have to allow some room for people who can do really unusual, creative stuff to do that. That if we have a budget that's 100% dedicated to the old paradigm, maybe we should start thinking about having 3%, 5% dedicated to this possibility that what I've described is true. Because if we don't do that and we don't have any non-status quo solutions, when we get to a future that's shaped a little bit more by disaster than design, we'll just start using whatever's lying around as a solution set. And my argument is that we probably need some really completely different solutions to enter this different world. It means that if you're a country or you're a company, it means that this is no longer a feel-good slogan, reduce, reuse, recycle. It means this becomes an operating imperative. It means the winners, countries or companies, are ones who do this better as a matter of course. It means the losers are the ones who can't figure this out because they can't adapt to the new thinking. It means that we have to fundamentally get the story right. We have to change our narrative. What do I mean by that? Stop me if you've heard this story. Houses always go up in price. That was a story we ran in our heads, an international narrative, until about 2005 and 6. Then we realized, whoops, that was actually the wrong story. It was a bad story. A lot of things happened because we were running the wrong tape. What happened was we had huge amounts of malinvestment. There are billions, if not trillions of dollars of losses associated with horrible decisions that were made because we had a story that said houses always go up in price. So the question before us is, what other stories do we have out there that could be just as obviously true to us today that might actually be false? What if one of those stories is we need to have economic growth? If that's part of the story and it turns out that's actually not the right story, then it means we're going to expend an enormous amount of energy in pursuit of something that could turn out to be harmful rather than helpful as we go forward. So as I look forward in the world, I no longer think about left versus right, old versus young, Democrat versus Republican, rich versus poor. None of these things matter to me anymore. I think that because we're in the last few minutes with that water coming up the stairs, that now we're down to the critical component of, are we making the right choices or are we making the wrong choices? Because when you're in the last few minutes, choices get magnified. You can make all kinds of mistakes early on in the story, right? The first 45 minutes, you have lots of times. You're going to try the bent paperclip, that didn't work. I'm going to shout for a while, nobody came. You can try all kinds of stuff, right? But when you've got just a couple of minutes left, the importance of your decisions are magnified. This is how I think our children and grandchildren are going to be measuring us. What kinds of decisions did we make at that critical moment when we had all of this data before us that said, ooh, things have really changed? So what do we do? I wish that we had the time right here, right now, to really delve into the full implications of what I've talked about, but we just can't. The implications are enormous, obviously. This could change everything about what you do, where you work, how you think, in your community. There's all kinds of things that arise. So what I would ask you to do is to go to my website where we have a large active community of people who are thinking this through, because these aren't trivial. Many of these changes will take quite a bit of time to think about, to develop intelligent responses to formulate actions and reactions. A lot of this material raises, I admit, some fairly profound implications. What I would leave you with, though, is the concept that this doesn't have to be scary. This doesn't have to be something that raises anxiety or fear. That there are many people, myself included, who have stepped through this material, made positive changes in their lives, and actually feel like they have a higher quality of life today than they used to have, even though they may be living on slightly less stuff. So this is a message of opportunity. This is a message of hope, if you care to look at it that way. I am giving you the gift of time to adjust, to look at this story and think about what you want to do and how you want to approach this. This is a message of true empowerment because you have the opportunity still, the options to change your life however you want to in response to this information, ranging from no change whatsoever to gigantic changes. And if you come to my website, you'll find people who are on both ends of that spectrum and everywhere in between, and that really this is about the journey. So please come, and thank you very much for your time and attention. I look forward to seeing you at the website or perhaps somewhere else.
Thank you.